Assalamualaikum. So we are from Group 7 for Project Security Network proposal. So my name is Iswan Hakim and this is my group member. So in our project, for our network setup, we start with requirement analysis to identify key hardware component. This includes understanding devices like routers, switches, firewalls, servers, and how many each are need to support connectivity. Communication and security. The goal is to ensure the network is reliable, scalable, and capable of handling both current and future needs, allowing smooth communication, secure access, and efficient data transfer. So for secure external access, we use a Cisco ASA firewalls 5506X to filter packets and block unauthorized access between our internal networks and the internet. The MZ was set up using a Cisco 296024TT switch to connect public service like the web server and email server, ensuring they are isolated from the internal network. The internal LAN uses two switches, which is switch 1 connect to employee PC for high-speed communication and switch 2 connect to the web and email servers in the DMZ. So router 1 handle external connection to the internet. So this is our demonstration where we will show our network design and testing results. Our design consists of three main departments, which is inside, the MZ, and outside. The routing in this topology is done by using static routing, where we manually configure routes between the networks. In the outside department, we have a server acting as the internet lah. While the inside department, we have two PCs, which is PC1 and PC2, and the DMZ department hosts a web server and an email server. The firewall configure to control flow and allowing only specific traffic types such web and email service, ensuring that network remains secure from unauthorized access. So in our design, we have several security implementation. So for the first security we implemented, which is, for example, in this design, we have firewall. So let's say only unauthorized access can configure this terminal in this firewall ASA. So let's say we implemented, we're going to enable and then the password. So we set up the password, for example, Cisco. So completely. So after login, the user can configure the password. So we can after we set up the password, we encrypt the password, so which is secure. So in here, in here we can see the password, which is supposed to be Cisco, but already encrypted. So this is our first implementation, security implementation. Okay, so this is our design. As I mentioned, our routing is static routing. We already configure for this part, which is the IP for PC, IP for the firewall, IP for in the outside department, IP for router, internet, and DMZ, IP for switch, IP for email server and web server. So I will show the configuration. So this is our configuration, like basic IP, like I put IP address and subnet mask and no shard. But after that, we put names and security level for three interfaces, which is inside the MZ and outside. So for example, supposed to be inside, we put security level is 100, and then the outside, which is zero security level, which is untrusted. So inside supposed to be trusted. So the MZ is restricted. So the MZ basically is accessible for inside and outside. Yeah, this is example for the command. I put security level 60 on DMZ, 100 on inside. On outside, I put security level is 0. So this is basic. So I already set up a default route, which is tell the router to forward packet for unknown destination to a specified next hop. So I'll show you the command that default route, this one. So route outside 000, okay, this one. So This command set up a default route on the outside interfaces. It means that any traffic that doesn't have specific route will be sent to the next hop addresses, which is this one in the outside. About so right now phase 2, which is configuration firewall policies. So right now you have by default we cannot uh, in firewall we have to set up NIT to make sure the PC from another different department can communicate or ping each other. So by default we cannot, for example, for PC1 to from the inside ping to the MZ web server. Actually we cannot by default. So in here phase 2 we have to translate IP address. By doing that we have to configure NAT first, which is create object. Basically NAT have three types. We're using dynamic, so I will show the configuration. So this is the actually the configuration. To do NAT we have to create object first, which is oh, I forgot to put the subnet in this our design. We do two subnet actually, which is the MZ outside and inside outside. So this is the NIT we doing. So the first object we create is the MZ out for and the subnet, and then the NIT we choose dynamic interfaces, and subnet number 2, which is object network inside out subnet. So let's say PC1 trying to access the web server in here from here from PC in the inside to the MZ. So the firewall is basic by default it will block the access from PC1 to web server. This one, the firewall block unless we implement the policies, which is access list. So this is one of our security implementation, for example this. So I will show the configuration. So for example, this is the access list that we implement to the MZ access. So we create in this phase we create two access lists, which is the MZ access and the internet access. Actually we can made up this name of access list anything. So for the first one, this is example, okay. We create the MZ access extended and permit. We have two options actually, permit and deny. So ICMP means we actually can ping from any interfaces to the MZ. So any from outside and inside can access the MZ actually. So any means from any interfaces. So I will show the after that, before I show the ping, the testing. The, at the end of the at the end of the this configuration, this one we create the access list is just policies, but to input into action we have to apply the rule, which is this is the rule. We have to create the access group. Yeah, we have to create the access group. So right now we actually have create two access lists, which is the MZ access and internet access. So this one I will show the apa ni, the testing. Suppose to this PC1 can ping the IP in web server. I'll show you. So this is the IP that I put in web server. Let's say in here we ping the from PC1 to web server. Suppose can. Yeah, right now it's can. So actually the simulation actually I'll explain. When PC try to access, he come here. Before he going to read the access list, he have to read this first. For example, DMZ access. So this is the rule. This is the very important thing. If without this is useless. I mean, it will not run the access list. So this is the crucial part lah to implement. So it will approve and permit to access this web server. So just now I'll just show this one part. This one, the MZ access. Let's say we want to internet access this time, which is at the outside. This is the internet. We want to open the browser from the PC1. Let's try the testing. So this is okay. You want to go to web browser in that. Wait, yeah. Supposed to be in here. like this. The IP same with this web. So see, we can to access the internet from this command, this one. So we can access the outside from the inside. Yeah. So just now I just showed the configuration which is in the DMZ can be accessible from any interfaces. So and the the outside which is internet can be accessed which any interfaces. I mean, like for example the any I mean this one, this one, the any. So right now I'm trying to prove that actually we can implement the specifically implement on the device policies. So let's say for example I want to configure PC1 and PC2 to email server. So I want to try to make send this PC1 email to PC2, but using the email server. So I already configure in this one, yeah, PC1 and PC2. This is as email server using this wizard.com. So this is example. So let's say employee one trying to send email to PC2, but I want to prove that we can specific the PC cannot the PC and PC2 only can access this the email port, yeah, using the email port. So but the PC cannot ping the email server IP because this is I configure this is specifically for the email only. So let's say I'll show the configuration. So for example in this one I'll show this is the, for example, what is the port in email. So I search in Google. This is the list of email port which is port 25, port 465, port this one. So let's say uh, I I want the in this area, inside area, can using the email server but using email port only, using in here in the DMZ. So let's say this is the configuration, which is I type 192, which is this the whole the default gateway. I type in the subnet and then host to the specific IP, which is this is the IP for the for the email server. So that's the IP for email server. And then I try to using port SMTP. This one, like I just said, the port of email. So this is after that we already create the access list name, which is DMZ access, and then I create new access group, which is this DMZ access. This is like the rules to send the access to the DMZ. After that, I'll show the testing. So let's say we can use the email, for example PC1 and PC2. So this is the PC1, PC2. I'm trying to email to the PC2, for example. I compose email for PC2 actually is email dot wizard.com subject test. This is also test ABC. Okay, send. So the PC2 will receive the which is successful to send the email, but I will show when I try to ping the email server, it will request timeout. This is the proof. Let's say the IP of email server is this. I try to ping. So it's supposed to be shown show the request time. See, it requests timeout. Because why? I explain in this part I only create access list for the email port, not the ICMP and anything. So actually what I'm doing is I specifically implement device policies. This is the example. So the security implementation here that I just implement in here access list, which is port 587 in here, and 995 and 993. So this security is these rules allow secure email protocol SMTP with authentication, POP3S and IMAPs, which is just encryption for safer communication. So this is the security implementation in here. So we have two switches. We just update the security implementation in each this switch. So for example, Number one we implement is BTY line security or remote access security. So as we can see, I show you the coding, the command that show line BTY. So this is line BTY. So this command configure remote access for the switch. So first we set a password for the first 5 BTY lines, line 0 to 4, using an encrypted password. Then we enable login for these lines, meaning user must enter password to access the switch. Yeah, I think that's it. And number two, we implement secure switch port. So this is secure switch port. Secure switch port where? This one. So I implement on to PC1 and PC2. So this secure this we secure the switch port fast Ethernet 01 and F02 for PC1 and PC2 by setting them to access mode. This allow only one device per port. We enable port security to block unauthorized devices and use sticky MAC address learning to save the connected PC MAC addresses. So this ensuring only those devices can connect. Yeah. So number three is BPDU guards on switch. So this is BPDU, this one on here, spending 3 BPDU enable. So this is enable BPDU guard to block any potential spanning tree protocol (STP) attacks, such as rogue switches sending BPDU to your network. So number four is dynamic ARP inspection, DAI on switch. So this is this one. So this show protect against ARP spoofing. So this feature prevent attackers from sending fake ARP message on the network, which can lead to man in the middle. Yeah. So this can prevent from that happen. Yeah.